Okay, so there are last two topics which are remaining. One is the payload installation and utilization, and last one is the drone data and analysis. Okay, or image and video interpretation. These two topics are basically an introductory topics. These are not really plays any role from a perspective of flying the drones or from a licensing perspective. Whereas these are topics to start or think about how and what could be the utilization of the drone and how you can scale up further on after your licensing is happening. Okay, once you are a licensed pilot, then you can think about what could be the utilization of drone, whether I want to be utilize my drone for agriculture purpose, or I want to make the forward path into the agriculture segment, whether I want to go for surveillance, whether I want to go for aerial photography, or whether I want to try into the delivery section, supply chain section, or monitoring, or maybe different types of applications of the drones. Could be windmill tracking is there, solar panels are there, gas and pipelines are there. Kind of project sometimes takes almost six months of period. Like as we said, we did the power line tower activity monitoring and surveillance activity. We did POC for only for 100 towers. That itself took us for more than 6 months, and we were talking about the actual project of 16,000 kilometer lines. So there were approximately 12,000 power lines towers. So imagine 12,000 power line towers को अगर surveillance करना है, how much people would be required, how much drones would be required, how much data would be coming in there. So it is such a complex and such a large project. So it was initially envisioned for 3 to 5 years of project, okay, to begin with. So it has a multiple phases. So they wanted to start with one particular segment with 1,000 towers first. Okay, so they have given us only as a POC 100 towers to do it, and they were actually asking us to draft a way we have encountered the challenges, encountered how to do the procedures, how to do the monitoring, how to get the data. All that things was learning for us during that POC activity. So whatever we have done during the POC, we were asked to submit that in a form of a report, and probably asked us to take it over further on for a project. But by the time it got materialized, I was not working for that particular organization, so I do not know what has happened. They are still in engage because still that is not been started. Now the latest what I heard from the company or the board is that I understand that board is wanted to set up their own drones unit. Okay, so they wanted to purchase their own drones. They want to set up a people. They want to hire a drone pilots and the analyst who will taking the data, configuring the data, and then the software segment of also it. So there are a lot of back and forth is happening. Sometimes board is saying that we'll outsource certain activities to vendors. There would be some activity which will be carried out by the internal team also. So that's how they have wanted to do it. So that is what I heard the last discussion. So now coming back to the topic, our payload installation and utilization. So what kind of payloads we can install? So any idea what all the payloads we can attach to our drones? What type of payloads I can attach to the drones? Of course, I know the camera is one of the thing. Apart from camera, do you think anything else we can attach? No? Okay, so let's move ahead. So basics of payload, types of payload, and payload applications. Okay, these are the components of this particular module. So there are different visual light optoelectronics payload, night vision optoelectronics payload, first aid kit, okay, or first responder, what we call it is. Okay, there is one good video on the YouTube also where the person was having a heart attack, and that lady actually triggers the help. Okay, and that help comes through the in form of a drone. So drone comes, there is a small package attached to it. She takes the package, and then using the camera of a drone, they are able to communicate with the doctor. So doctor through the camera of a drone is able to see the patient, and he instructs that lady to do certain procedures. Okay, so that person is basically having a heart attack. So they have bought a that device which they gives the shock. Okay, so that lady puts the shock and all that things, and that person is saved because of this first responded kit, which is available on the drones, which can be delivered using drones. Similarly, remote control loudspeaker. We have seen this application during the lockdown period also, or even during the Kumbh Mela. This was used, okay, to control the crowd or give instruction to the crowd and all. Okay, then remote control searchlight. This is widely used in wildlife or a location where we have to do a rescue and search operations in forest or remote locations and all the things. Then we have a very high-end optical zoom cameras, 36x HD cameras, or even nowadays 50x optical cameras are available for photography and videography kind of thing. Then infrared thermal imagers cameras are all also available, especially for solar panel, or if you want to monitor some components, like especially sometimes I want to monitor the gas pipelines. Okay, because gas pipelines or even water pipelines, they appear to be normal from the outside, but there are a lot of corrosion or a lot of issues are happening from the inside, especially like water pipelines. There is a continuous flow of water inside the pipeline. From the outside, the pipeline looks very good, but if from the inside, because of the water continuously flowing inside the pipelines, they become corrosive. And over the period of time, the pipelines are being utilized for years. Okay, there is external factor also affecting on that pipeline. There is also a water which is flowing inside the pipeline that creates a corrosive into that pipeline, and one or the day that pipeline will break. Okay, there will be some leakage or something would happen, or something breakage would happen into those pipelines, and that could cause a lot of wastage of water. So a lot of time they wanted to survey the pipeline from the outside for structural integrity. Okay, so a lot of time we use thermal cameras, okay, to get the or maybe some kind of cameras which actually penetrates the structure and gets the structural integrity of those materials. Okay, so that kind of payloads we can attach and get the footages also. Okay, other day I told you about the lights which have been put on the drones, and you can create images like display in the sky also. So those are all keywords. Okay, there is a light, RGB light is there, which call it as RGB light. So it will, if all the three lights are on, it will display as a white light. But if you just on the red light, it will be just on LED, red LED, green LED, or yellow LED, okay, blue LED. Sorry, RGB is red, green, and blue LEDs. If all three LEDs are on, then it will create a white light. But if the combination and the intensity of the LEDs, based on that, the color of the LED will be displayed. So that's how they create multiple images in the sky by putting on and off all these lights, or setting up the intensity of those lights accordingly. Okay, so what is payload? Payload is the weight of a drone or a remote pilot vehicle, that is RPA, can carry, or unmanned aerial vehicle can carry. That means apart from its own weight, the drone, okay, the payload is something called as additional weight which it can carry. Okay, so for example, my drone, the small agriculture drone, it can carry the weight of a 10-liter tank. So that is a payload for me, 10-liter tank and the motor attached to it. So it can carry that weight. So that is a payload for my drone. And when I say total weight of my drone is the drone weight plus the tank weight, the filled tank weight, not the empty tank weight, the filled tank weight is my total weight of the drone. It is payload, normally it is usually counted as outside of the weight of the drone itself, because that is how we differentiate what is the drone normal general drone weight and the payload weight, and what is the total weight of my drone. So total weight is the drone weight plus the payload weight. So that's why we always say payload weight is always counted outside the weight of the drone, and includes anything additional to the drone, such as extra cameras, sensors, or package for delivery, or even camera with gimbals, all that things. Like if you see here, camera sensor is attached to the drone. Or even if you see here, there are drones which are being connected with the camera sensor, as well as some missiles are attached to this predator drone. Okay, so or even if you see this delivery drone is there. Okay, so this is actually delivering a medical supply. So it lands this parcel. Basically, it drops when it reaches a particular latitude, longitude. It will message the particular owner that your parcel has arrived and it is getting launched from the drone. So he can track, he can see this in the sky, and it will drop from a certain altitude, and that person can safely get that delivery captured for him. Okay, so that's this basically parcel is nothing but a payload, additional component or additional weight outside the drone weight. Okay, what is gimbal? Gimbal is used to stabilize camera payload that have been mounted on drones and other autonomous vehicle. Gimbal integrates with an IMU that responds to motion and provides inputs to the controller that activates separate motors to keep the payload steady on each axis. So this is basically the gimbal. Okay, so gimbal is attached with the camera. So this gimbal attached to the body of the drone, and gimbal gets the inputs from the IMU. Okay, so IMU basically gives the inputs, and that inputs are taken by the gimbal to stabilize the footage of the whatever the object it is trying to take. Like this is a basic drone where there is a gimbal attached, and then there is a GoPro camera attached to it. Okay, or even these are little bit high end gimbal with camera. Okay, normally you will see this in DJI Inspire or those kind of devices where you have these high end gimbals with built-in camera itself. Okay, so this here you can only change the lenses. You can remove the lenses. You can remove the things, filters, and all that things you can put up on those lenses over here. Okay, so these are little bit high-end gimbals with camera modules. Okay, so what are types of electro-optical payloads? There are RGB cameras, thermal cameras, lidar is there, multispectral is there, hyperspectral cameras are there. These are all electro-optical payloads or electro-optic payloads. Okay, so let's see first type, RGB. What is drone RGB? The human eye is sensitive to red, green, and blue band of lights. Most of the standard drones comes with a camera that captures the same RGB band, so that images they produce recreate almost exactly what our eye sees. So same thing like how our mobile has a camera. Similarly, the same RGB camera is there on the drone, which captures exactly the same what we see through our eyes. Okay, that is the function of the RGB camera. This is a basic normal camera I am talking about. But nowadays, the cameras what we are utilizing on the drone, they are called as smart or high-end cameras. Okay, so with an RGB camera on your drone, you can see the entire field. So there are something like wide field cameras. Okay, and by processing aerial imagery into an orthomorphic map, quickly make observation, enter the geodata into your GPS, and drive right into the problem area without damaging your entire field. So by using drone cameras and the software, photogrammetry software, you can make these kind of pictures. Like you see here, this is all normal pictures, but here you are getting a orthomorphic map. Okay, it will tell you whatever the data, how way you have configured your software to derive to the orthomorphic maps. Okay, so this basically map will give you the structure of your farm and give you idea where what is required. So accordingly, based on your inputs and your interpretation of the image, you can take the decision. Okay, based on your image what you have captured or data what you have captured, and accordingly you can take the corrective actions so that further damage is not happening to your land or to your crops. Okay, RGB camera, a visible camera sensor and imager that collects the visible light between 400 to 700 nanometers and converts that into electrical signals, then that organize that information to render images and video streams. So if you see here, different types of same land it has captured, but it is showing in a different way. Like if I want to see what is the mineralization, what is the seed rate I would require, what is the soil organic matter is required, or I want to see it from the DNI or denitrification zone perspective, I can see and decide on these inputs. I can see whether how much pesticide I need to put or what kind of fertilizer I can want to use. So this is something like a monitoring perspective. So using the same camera, but addition to that, there is a software which uses and interprets the results of the RGB inputs, and it gives you this kind of maps, okay, or render the images. Okay, also there are RGB cameras where the camera itself has a inputs for stabilization, the software stabilization of a video stream. Since your object is moving, your drone is continuously moving, it should not have a shaky videos or bumpy videos and everything. So there are a lot of software stabilization is been provided based on the input captured by the camera itself. So it is a real time stabilization is happening between the drone and the camera when it is actually capturing the footage. Sometimes even object tracking is also there. So video process the steers the gimbal to maintain the object of interest inside the video frame, even if the object is moving and aircraft platform is moving. Like for example, your drone is moving or your object is also continuously moving. Like you want to take a footage of you are taking a event of, like, let's say cycling event, and you want to track a particular cyclist. So what you will do is you will focus your camera to that particular, or you lock the camera to that particular cyclist. As he is riding his cycle, it will lock and it will keep on flying, okay, by stabilizing the inputs also from the drone. And as both your object as well as your drone is also moving, the inputs from the camera will be help to stabilize and focus on a particular object only. So this software stabilization and object tracking is also now possible in the newer RGB cameras, because they are called as smart cameras. Okay, so application of RGB camera like traffic monitoring or crowd monitoring, I told you about Kumbh Mela and all the things, or even for the crowd monitoring with respect to or vehicle tracking also can also been done. Okay, so a lot of time it can read even your number plates, and then it can instruct the law enforcement policy. Like rather you keeping continuously monitoring, you can always fly the drone on the highway or near the toll location or toll section and track a particular vehicle without that person knowing that he has been tracked or been observed. Okay, so he will normally see it is just a drone flying, but the drone is basically capturing and giving inputs back to the control center. Okay, and based on that they can find which car is what and where it is exactly. Okay. Again, in disaster management, drone can be used for fire detection, intervention monitoring, and also for post-fire monitoring also. Okay, so in wildlife sectors or disaster scenarios, like could be a fire. Most of the time in forest we encounter this kind of fire. So basically drone would be very useful to control, or even sometimes some drones are used to put off these fires also. We have seen drone are been designed in a such a way that they have been now started adopting, like near future, maybe in next 1 year time, all most of your fire department will be upgraded with the firefighting drones also. Okay, so there are a lot of couple of OEMs. There is one of the OEMs in Mumbai also, and there is one OEM in Dhule also, who are actually developing a drone which can spray the water on the fires, especially when we are talking about high-end towers on all those things, big buildings. Definitely we need this kind of solution in near future. Okay. Again, we talk about border security. A drone can quickly fly over and detect the threats and provide aerial images and real-time footages. Right. So if you have a drone flying across the border, we can keep on tracking our motion movements on the border. Every time it is not possible for a soldier to go near the border and check, because most of the time the posts which are there on the border, they are away from the border. They are almost like 2 kilometers, 5 kilometers, 10 kilometers away from the border. They are not exactly at the border of because they have to cover large areas. So they will be always behind the border, at least like 5 to 10 kilometers away from the border. Okay, so that is the reason why if you see on the airspace map of India, 25 kilometer is the space which we called it as a no man's land. Okay, so your post will be normally away from that location. Okay, so ideally only the army is allowed to fly the drone in those segments. They will be doing the patrolling over the border area using drones. So physically it is not possible to cover such large areas and all the things. So drone is a good solution for such kind of scenarios using RGB cameras. Okay. Again, what is the application of RGB sensors or this use of unmanned, increasingly complex, completely automated drone inspection has caused a huge waves in asset management sector. Like for example, towers are there, telecom towers are there, windmills are there, or for example, rigs are there, or even ship containers are there, or even where the containers are getting shipyards. Those container loading locations are there. All these locations they have started employing or deploying their drones for their day-to-day work. Okay, so that aerial surveillance you can do. Okay, you can get a real-time update, real-time stock, real-time information about the movements and activity happening at these particular locations using RGB sensors or RGB cameras. Okay, what all? So in total, let's see what all the applications of RGB sensors or RGB camera. They can be used in solar farms, wind farms, railways, bridge inspection, power lines, mobile phone towers, oil and gas pipelines, water pipelines, buildings and construction, real estate. Okay, in real estate segment also it has been utilized to show the progress of the construction or development of your building. All that things you can showcase to your customers or to your stakeholders, or you can attract more future customers by showing what we call as what is that called, over the timelines you will see how you have performed or how you have done the progress of your work. Like last month it was only 2 floors. This month our footage is showing 4 floors, so in 1 month we have overcome or built 2 more floors. That progress you can show it. Chronological updates you can provide to the customers or to the future clients also. Okay, application of RGB is again for mapping purposes, where we can, if we are having a fixed camera, you can have a 2D mapping, you can do it. But if you have a gimbal with it, then you can take the photographs in a different angles and all the things. You can do a 3D mapping also. Okay, so depending upon what camera and what gimbal or what payload you are attached, based on that you can create different images or different footages of that particular location. If it is fixed camera, then it could be a 2D mapping because you are horizontally taking the pictures. But if you have a gimbal with a camera, then you can create 3D mappings also. But then again, when you are configuring the drone for such kind of activity, you need to plan how and what photographs and how much photographs are required. For example, when we were doing a power line tower surveillance or monitoring, we initially were taking only 100 photographs, but that was not enough for us for do the surveillance and monitoring of the drone. So then we increased to 300. Then we also saw that no, we need to have more number of pictures. So in that scenario, we have gone up to almost 500 pictures per tower. Yeah, Jagjit.
So I have a question, sir. You said the images that the pictures that we take will be in the range of 1500. Whatever the pictures be. But is there a way in which the pictures, because using IoT, you can transfer the pictures and then you can delete the memory and then restart it.
You can do that. You can have your drone configured in such a way that your pictures are directly transferred to the cloud also. But since you are doing this in very remote location, we do not know how the signal would be there. So ideally, when we were doing these pictures, we will do is that we will, once our drone is down, for a battery change, and then that point in time, even we'll remove the chip and transfer images also immediately on our laptop. Okay, and again we'll put, or maybe we take that chip. We will have multiple chips with us. Okay, so we'll chips will be also be numbered like 1, 2, 3, and 4. So I'll be one, like I start with battery one, I will put one chip. I will use that chip to capture. If my chip is capable of taking entire footage, like huge chip is there, 64 GB ka hai ya 128 GB ka hai, it is more than enough for me to capture the entire drone. So I will not normally remove that chip. So I will keep on capturing in that chip. By end of the day, I will transfer all the data at the end of the day. So depending upon what capacity I have to capture the images and data, because 500 photos of high resolution probably was more or less like 1 or 2 GB of data. And then videos also I used to capture 360-degree videos of the tower. So in totality, I used to have almost 4 to 5 GB of a data of one particular tower. Okay, this is I am talking about RGB data. Okay, then I would have a thermal data, then I would have a lidar data, all that thing. So imagine somewhere around 6 GB of data I used to have in my drone. So end of the day, I have to transfer that data evening mein. My pilot used to transfer it with the with the name of the tower or the number of the tower, with the date attached to it, and then used to transfer it. Initially, it was also very challenging for us because this data what we transferred on a laptop was accessible to only one single person because it was accessible on that laptop itself. This was a big challenge for us. So later on, we found out that we will we'll purchase a data on cloud. So after having the data on laptop, in a week's time, we started uploading that data into the cloud storages. Okay, so we uploaded in a cloud storage so that it can be accessed by multiple people from multiple locations for multiple purposes. So there were people who were accessing the images and they were creating the reports. There were people who are using the video footages for checking the videos and all the things. There were people who are from the thermal segment. They were actually analyzing and trying to find out the anomalies from the thermal. Lidar people were there, and then there was a segment separate software people who were there trying to integrate all this data into one single view pane, so that I just click. So there was some software was developed where I can just click on that particular mobile on particular that tower. It used to give me a complete statistics of that particular tower. So whatever data, whatever the images we used to capture, it used to be fed into the software, and that software will used to give me the real time status of that particular tower. So for example, if that particular tower is been taken footage twice in a month or twice in 3 months, so it will tell me when whatever the images or whatever we are seeing on it, it will tell me what is the latest one. It is based on the latest, it will give me the status of that particular tower. So when we did for 100 towers, we found almost 80 to 85 percentage of towers having issues. Some or other issues were there. Okay, so we brought those towers, we brought those data, we generated the report, we shared that report to the board took the data and instructed their OEMs to rectify those problems, and we were asked to fly the drone again on those 100 towers after 3 months period, 3 to 4 months period. Okay, so whatever the first tower we did initially, we started with the same tower again. Okay, because that tower would have been addressed first. So that sequence we followed, and by the time we completed the 6 months, we have brought almost what we say from 85% of tower having problems, we brought it to 10%. So that was the proactiveness what has brought into it, and all the major problems were eradicated. That's how it has reduced the outages of the power lines over there, right?
Yeah, you got that, sir. Thank you.
Okay. So application of RGB, as I told, in mining is there, erosion detection, boundary management, project progress monitoring, all that things. Even in the construction segment, mining sections. Okay, even if you are want to like you are developing, let's say in some segment you are developing a dam. There also you can deploy a drone and you can regularly take the footages because dam would be a big area. Practically it is not possible to visit every location and regularly take the photographs and all that. Earlier, people used to do all these things manually, but still you do not have to have enough data. But right now, because of the drone getting employed for such kind of activity, you get a very good footages in form of a photographs or in form of a videos also. So you have a good progressive reports available with you. Okay, so which can help you to showcase to your even executive committee or executive management to show the progress of your projects and your activity happening on field. Okay, without going actually physical to the site.
Sure, sir.
Okay, so that was all about the RGB cameras. Similar to RGB cameras, we have thermal cameras. Now RGB cameras is just a thing what we physically view or physically we see it. Okay, but thermal is basically nothing but it captures the heat sensor. It's a heat sensor that is capable of detecting tiny differences in temperature. So this tiny differences in temperature creates the thermal images. Okay, so basically this device collects the infrared radiation from object in a scene and creates an electronic image based on the information about the temperature differences. Yes, Jaishil.
So just wanted to ask, what is the stretch limit of a drone? Means whether it can be utilized when it is raining heavily,
In rain, we
or
do not fly the drone.
correct. And even for temperatures, like sorry, if we somewhere in Rajasthan or somewhere in Leh Ladakh, so
So you
does it
have,
have an upper and a lower
yeah,
capacity
yeah, yeah,
to
yeah.
work
Got
at
it, got it. So
temperature?
what would be the operating
Correct. What is the
of,
stress level it can take?
yeah. So whether in a cold scenarios or in a hot scenarios, whether your drone can fly or not. So there are various components to it. Okay. So like, see, drone as a frame is a physical or just a passive component, but there are some active components like your flight controller, your motors, okay, or your propellers, or even your battery. Okay, these are the devices on which actually the climate or the scenario, like whether it is a cold or a hot temperature, can affect. So during the type certification, these scenarios are tested. So there is something called as a heat test, or there is a something called as a cold test. So based on the type of a by type of the drones, you have the certifications available. So based on those reports, you can see whether your drone can sustain that extreme heat of Rajasthan, or whether it can sustain the extreme coldness of Ladakh or Siachen Glacier and all the things. So there, as I told yesterday, there was a competition for testing the drones in the Siachen Glacier locations or Ladakh locations. So there were a lot of people who have taken participate, and there was one company. Uh, I don't remember the name of that company which has won that competition. Okay, so in extreme cold temperature, it can perform very well at that high altitude location.
Height, yeah, because the air is very thin there.
Yeah, so high altitude location, that drone was able to fly. Even the Idea Force drone has been part of. I think it came second or something like that in that competition and all. Okay, so that is about the drone. Then where what these payloads, so again you have to see the specification document of these payloads, whether in that extreme heat or in that extreme cold, whether these devices can function or not. Okay, so based on their specification document, you have to use, or there are some casings are also available for those particular payloads also, where it can protect the payloads from those extreme conditions. Okay.
But for rain, it won't ever work, right?
Rain, as of
So
now, there is nothing possible because
suppose if it is
motor
in the
motor
fields of
itself,
Assam somewhere.
yeah, motor itself is your open or component. So the moment the water goes into the motor, there could be a possibility of some short circuit and all the things can happen. So as of now, there is not much drones been developed for those kind of, like people are flying. I mean, DJI is saying that you can fly our drones in rainy season also. So people are flying those DJI drones in, because they are making those drone waterproof or kind of thing. The material what is being used.
Not only waterproof, then you will need to have SAR cameras also, synthetic aperture radars, right? On that
Yes, yes,
basically,
yes.
which will
So that
look
is
through
on
the
the
rains.
payload. That is on the payload side. Okay,
Correct.
so they
Both
are
on the
talking
payload
about,
and the drone. The if that is if it is going
correct.
to go in heavy rains, the modifications have to be on both of it, right?
Correct, correct, correct. So as of now, that is not so much utilization in the rainy season or rainy type of environment. But eventually, people will working on it, and all that things will happen and come in. Okay, like DJI also initially, if you see initial drones were not equipped with waterproof or the IPS values, what they call, IPS 97 or something like that. If it is certified as IPS 65 or 97, then we say it is a waterproof kind of equipment or a drone and all the things. So until unless those things are being not tried and tested, you will not have those. There are certain like Air DJI Air 3. They say that it is a, you can fly in a rainy season also. It will just become a wet from the outside. Okay, but still water is water. Moment it finds, because there is a little bit gap when you are putting the battery at that though the battery is been designed, the battery component is in designed such a way that direct water will not go inside. Okay, but you never know, the moisture is there, it can
Correct.
always go inside or suck and all that things happen. So
So it is yet not a truly all-weather. I
yes,
mean that
we do
capacity is
not
not
have a
there.
all weather kind of drone as of now. Okay.
Got it. Thank you.
But these are, we are talking about the multi rotor kind of thing. But if you talk about the fixed wing, okay, they are powered by the IC engines and all those things. Predator drones
Right.
and all.
That, yeah, yeah,
Those are
those are all.
those are all equipped with the radar, multi weather
Yeah,
kind
yeah,
of
that
drones. Okay,
are all.
because
They are all
their
weather. They are,
functionality is completely different. Okay, they are like aeroplanes only. Okay, as
yeah,
good as
yes.
it is an aeroplane. So there you can fly those drones into
So military drones are all weather only,
all
basically.
weather, yeah,
Otherwise,
because
the purpose would be defeated.
their specification, like if we for us, if you're designing any component, it is at a standard heat and all that thing. But for military for purposes, the components are completely designed with different specification in itself. So similarly, when Adani and Israeli government are designing drones for Indian governments, their specifications will be very different, and those specifications are not available for general people. It will be a very confidential and all those
True,
things,
true.
right? So talking about the thermal camera, thermographic cameras or infrared camera detect the infrared light or heat invisible to human eye. Okay, so this is nothing but heat sensor that is capable of detecting tiny differences in temperature based on the data what it gets based on these temperature differences. Electronic image is created based on the information about the temperature differences. You can see this thermal images is being created. Okay, these are very expensive cameras. Okay, thermal cameras can cost you something around 2 lakh rupees or more. Okay, especially this company Clear FILIR. Okay, application of thermal payloads originally developed for surveillance and military operations. However, these thermal cameras are now widely used in building inspection like moisture, insulation, roofing, etc., firefighting, autonomous vehicle and automatic braking, skin temperature monitoring, industrial inspection, solar panel inspections, power line inspection, pipeline inspection. I gave you examples of this. Wildlife monitoring also. A lot of time we use thermal payload to track the wildlife also, motions of the movements of the wildlife or movements of the wildlife from one location to another location. Using the thermal payloads we can detect all those movements. Or pipeline, water pipeline, gas pipelines, power line inspection, solar panel is very extensively used by the thermal payloads. Okay, industrial inspection, skin temperatures, windmills, structure of the windmills under the thermal, these things also have been taken and inputs have been taken. Okay, so application of the building inspection, moisture insulation, roofing, so you can see how you'll see the building from outside. Okay, that is how you can take off. You can see here there are some deformities. Red are actually the temperature deformities you can see here. Firefighting, okay, you can see the building on fire. You can see during that also you can use thermal to how to see the source of the particular fire or particular location, or where you need to put the water, so that you can control the fire in shorter time. Okay. Autonomous vehicle and autonomic braking. So as I told you, we can track the vehicles or people, and you can control the movements of the people and all that things. Okay, so that is also possible using thermal payloads also. Skin temperature. This we have seen lot of time. The thermal cameras have been used at the airport or at the security locations. During the COVID times, we have seen the application of this, where it without touching the person, you are able to detect the temperature of a person. Okay, even in industrial inspections, especially in big industrial segment like pharmaceutical plants or where the fertilizers are made, big farms, big industrial installations where it is very difficult to check each and every component. There we can use drone with the thermal payload to get the real time data and all the inputs what is required for them to monitor and come to the conclusion what is required to be changed and what is not required to be changed. Okay, solar panel inspections also we can do, so you can get the health of our solar panels, how it has been impacted, because physically or visibly it is not available for us, the panels. Okay, the glass panels what is there. So in a thermal section you can always find out whether any panels are gone faulty or wrong based on the thermal inputs what you see on the footages. Okay, power line inspections also. Lot of time because of the heat, because this tower is completely subjective to the climatic situations or situation. Okay, lot of time is not physically or visibly available for us. So when we take a thermal inputs of the tower, we'll come to know whether any particular structure on the tower is under the stress or in a deteriorating conditions, or even the wires. Okay, lot of time it is not visible, so sometimes wires where the power is getting transmitted, because every wire will have a resistance. Okay, this is a huge voltage is flowing through this wires, and this there is a voltage, so there is always heating inside these wires. So because of this heating, the wire would have gone through a lot of stress and all that thing. So a lot of time, because of the heating or this thing or change in the structure of the wires, these wires also get cut. So if we take the thermal images of these wires and the structure of the tower, we come to know proactively where what is change is required. Okay, so a lot of time there is a stress on the edges of the tower. They try to keep as stable as the tower and everything. So a lot of time the insulators get broken or they get damaged. Okay, sometimes because of the bird, sometimes because of the fire, or sometimes because of the continuous exposure to the climatic, that scenario, those insulators get breakage or damage or get burn out. Okay, so that time is not visible for us. So a lot of time it is not what we say easy for a human eye to detect all these things, because the tower is such a height and all the things. So drone has capable to take those footages and provide you. So imagine initially when we did the data for 100 towers, we did initially 10 towers only. Okay, and imagine we had 100 photographs of each tower. So 100 into 10 was like 1000 photographs. So seeing that 1000 photographs, for us initially we were very curious to see and find out, but over the period of time it was very stressful and fatigue for us. So we deployed a AI solution for it. So AI, we trained the AI model, and which was able to detect certain anomalies. So initially, my AI model was accurate of 55 percentage. Okay, when we started it, but by the time we completed our project, our AI model was somewhere around 90-95% of accuracy on whatever the model I have trained. Okay, which models or which anomalies which I have not trained, it was not able to detect them. But whatever the models or whatever the anomalies or defects I have trained my software, it was able to detect up to 90% very clearly. Okay, so if I have given a photograph which has a nut bolt missing, okay, so it was able to detect it from the photograph a particular location and mark that location where it says that the nut bolt is missing, or maybe insulator has got chipped or insulator has been broken. Those defects it was able to find, or a base tower with missing number plate or missing danger plate or missing rods on the base of the towers. Okay, these defects were able to find by my AI software. Okay, because human it was very difficult to check each and every photograph. Like in one tower, 500 photographs. It was a inhuman task kind of thing. So it's very difficult to see, because those are very high end resolution photographs. So we have to zoom each and every part of the picture and see and find out the defects from it. Like nut bolt missing हो गया, या member bar crack हो गया, break हो गया, missing हो गया. There could be the insulators. Sometimes there are a lot of time false images were also created, because the footages what we captured from the images, different lighting scenes were there. Okay, so ideal scene for me to capture the proper photographs of a tower was from 11 a.m. till 3 p.m. or 4 p.m. max. After that, when the sunset is happening or sunrise is there, lot of times sometimes the dark images used to come. So when I'm facing, my camera is facing towards the sun, either in the sunrise situation or in the sunset situation, those images were not very useful. But even those were informed for a software when you have to take it in a shadow perspective or a lighting effect perspective. So we need to capture the images in all conditions. Okay, during the sunrise, sunset, during the head on, or the sun is in on the top or head on that time zone. So we used to capture in a different time of a day and see and get the footages of that particular tower. Okay, so not only the RGB, even thermal were captured at the different times of day, because the temperature or heating of the metal part during the daytime or the evening time is different compared to the daytime, okay, or the noon time, what we call. Again, we have seen there is a differences in the images also that point in time. Okay. After RGB and the thermal, we have a third payload which is called as LiDAR sensor technology. Okay, light detection and ranging. It is a LiDAR sensor, uses light energy or lasers emitted from the laser to scan the ground and measure the variable distance. Okay, so it will continuously send the pulses. Okay, send the pulses on the ground, and it will get the readings from it, and that reading will capture, and that's how the image will be created. The 3D model of a will be created using a software. Okay, so LiDAR drones are any drones made to carry a LiDAR sensor. They are used to collect data that can be used to make a detailed 3D model for a variety of applications and industries. So depending upon whether you are doing a farm survey, or whether you are doing a mountain survey, or you are doing particular any, like it could be a food survey, like there was a project carried out by Geographical Survey of India to capture the entire 3D model of Daulatabad Fort in Ahmednagar. Okay, so they have wanted to capture. So they have asked couple of drone vendors, three vendors were appointed to capture the lidar data from using the drone and provide them the footages. Okay, and then they wanted to create a complete 3D model of the Daulatabad fort. Okay, that is what still in progress. Okay, so this was somewhere in last Diwali. This project was given to a couple of vendors, because even drone with lidar is not available in Indian market so efficiently. Okay, we do not see, and even if they are available, their charges are very costly. For example, they are charging somewhere around for a day 50,000 rupees. Okay, so within a day you have to utilize that drone with a lidar, and you can take the footages. 8 hours it is costing only to fly that lidar. It was costing around 50,000 rupees. So they will only give you the drone, sorry, not drone, the lidar. Okay, you have to attach to your drone and fly and capture the footages. Okay, so that lidar on rental basis is costing per day 50,000 rupees. So it's very expensive device. Okay, so application of LiDAR, which stands for light detection and ranging, is remote sensing technology. Okay, so LiDAR is used in remote sensing technology that uses laser beam to get information about surrounding objects. Since its inception, scientists has used LiDAR to map the Earth's surface and acquire meteorological data. Okay, so a lot of time agriculture, forest, weather people, they use LiDAR to acquire this kind of data. So it is basically LiDAR is predominantly used in remote sensing technology. Okay, it is called as a remote sensing technology. Application of drones in agriculture. Drones can help farmer to optimize the use of inputs like seeds, fertilizer, water, to react more quickly to the threats, weeds, pests, and fungi, to save the time crop scouting, validate the treatment, action taken, and to improve the variable rate prescription in real time and estimate the yield from the field. So this all this activity was earlier was done by farmer in a manual mode or a traditional mode, but by implementing the drone for all these activities, it can take a decision in a real time or in a shorter time. So earlier all these things activity was happening in a real time, but a manual or a traditional way, and a lot of time the solution was in a reactive way. Whereas regularly flying the drones, you get a real time images and real time inputs, where you can do lot of things proactively. Okay, until unless your crop is being eaten by the pest in a bigger scale, you will not able to detect. But drone has a capability to detect even a smaller effect on the crops, so that how you can minimize the damage and can control by later on taking the decision whether you want to spray the pesticides or fertilizers over there, or whether you want to increase the water on the soil and all the things. Based on that, you can improve your yield of your crop. Okay, that's how it is useful, the drones in agriculture. Similarly, the application of the drones in different segments can also help to improve. So another application of the drone is what we talked about, the light show, right? We can send multiple drones in the air. This is called as a swan technology. Okay, so you will say almost 100, 200,000 drones you can fly and create image in the sky. So this is especially done in the night. So you have seen during the Dubai festival, or even during the Ram that temple when it was inaugurated. Even that time also it was done. Even during the cricket matches, also the drones are light shows are being created. Even people during their marriages or any particular event, or if they wanted to do some kind of a marketing and all the thing, people fly drones. I mean, give order to those people who are equipped with this kind of technology. They have multiple drones and they can do this kind of publicity and marketing. Those companies are being awarded this kind of projects and they fly drones and all the things. So during this kind of flying and all the things, they have to take appropriate permissions and these things and define accordingly this thing, because there is a possibility that you are doing this kind of activity within the city itself. So a lot of times the cities would be there in a form of a red zone or a yellow zone also. So that point in time when you are doing this particular operation, you have to take appropriate permissions to fly these drones. Okay. So with that, we complete our payload installation and utilization topic. Okay, so we are left with the last topic of introduction to drone data and analysis. Okay, so we'll move to the next topic. This is the rather last topic of our as per the syllabus, and then we have something a small just overview of our digital sky platform. Okay. Okay, introduction to drone data and analysis. So from a flying perspective, this is not important, but this is from a future perspective. Like if you want to go into deeper, like you want to become an aerial photographer or a videographer, or you're capturing the data, how actually the data, as a pilot you should know how the data should be there or what kind of data could be there. Okay, so you should know the application of your drone. It is not about just flying the drone, but it is about its application of the drone. So, principles of observation, element of image and video interpretation, introduction to photogrammetry, and types of image and video data and analysis. Okay, this is just an introductory topic or introductory module. There is a detailed course which we are also working on the photography and videography section, where people will be actually flying the drones and capturing the various images, and then they will be doing post processing of those images. So that course is a separate course. We are talking with couple of people who are from this industry, like videographers and photographers who fly drones regularly and capture images and process. Those people would be doing all these things. Yes, Parag.
Uh, when do you expect this particular content to be available for training for
So we are
candidates.
talking, we are already talking a person who had working into the cinematography section for almost last 25 years. Okay, so we are in connect with him and he is actually developing. So we plan to have such kind of a course during off seasons, like when we are not able to fly our drones. So probably that point in time, wherever possible, flying the drone is limited. That time, these kind of courses will be ended. So there would be a course coming up for aerial and video photography for data processing kind of thing. There would be a course coming on GIS section also. Like we talk about the orthomorphic maps or 3D models or point in cloud models. Okay, DEM, DCM, digital elevation models or digital terrain models. All those image. So that comes under the GIS component. So we are also in connect with couple of GIS analysts on developing those kind of things. So probably in month of July or August, we are planning to launch those kind of courses.
By any chance, you will be connecting with candidates like us when these
Yeah,
kind
so
of courses.
whenever we launch, we will normally provide those inputs to our past students or people who are inquired with us. Also on our website, there will be update. There would be on our social media platform handles also. These things will come into the uh, available to the people. So people will know about it that when we launch this type of course.
Okay, thank
All
you.
our students will definitely know about it. So we try to, because you are already become a pilot, you want to upgrade or you want to do something addition on that one, you can always join those type of courses.
Yeah, would definitely love to do that, but
Yeah,
yeah, keep us informed.
yeah, definitely. So
Yeah.
principles of observation, you have to recognize the target is the key in interpretation and information extraction from those photographs. Observing the difference between the target and their background, involving comparing different target based on any or all of the visual elements of tone, shape, size, pattern, texture, shadow, and association. So this, if I give you example from my project which I did for Powerline Towers, lot of time whenever we see the images, we are trying to see the images, okay, the pictures. Sometimes we used to see that a particular location, there are locations where there are nut bolts. So sometimes that nut bolt looks very black. ओके तो ऐसे लगता है कि वहां पे नट बोल्ट है ही नहीं इट इज लाइक मिसिंग बट बिकॉज ऑफ द एंगल एट वॉट द photographs are been taken sometimes these are also a false images even sometimes when actual nut bolt is missing it is not visible in the images also that's why the reason we have to take multiple photographs of that particular target so that's what I'm saying observing the difference between the target and their background involves comparing the different targets based on any or all of the visual elements तो different angles से वो particular location where the bolts are connected or where the bolts have been fitted or where the insulator so sometimes एक location से insulator ऐसा दिखता है कि it is proper but other location you see that that insulator has been broken also so a lot of time this confusion is there when we capture the images so based on multiple images and multiple way we see these images based on the tone, shape, size, pattern, texture, shadow, and association will help us to identify or analyze those pictures and come up to the conclusion. Okay, whether there is a issue or there is a defect into that particular location or that particular object or that particular target. Okay, so tone is something like refers to a relative brightness or color of an object in an image. Generally, tone is a fundamental element for distinguishing between the different targets or features. Variation in tone also allows the element of shape, texture, and pattern of objects to be distinguished. So here I am showing a black and white image, okay, of a field based on the different color grayscale. It will tell me the type. Like this probably might be a fertilized or maybe a harvested crop land. This might be just a barren land. Here you can see couple of trees or structures which are made around the road. You can see this is the road which is going across the field and all the things. There you can see certain trees which are there or there are some empty lands, all the things. So based on the tone of the particular picture, I can identify. Like if you see this particular, this might be a green land in that particular area. Okay, wherever you see a white or grayish kind of structure, the surface, this could be a barren or open land structure where there is nothing being created. Okay, shape, again looking at this, again this images refer to a general form, structure, outline, individual objects. Like you can see here there is a field. Okay, track and field is there, or there is some fields are there, certain houses are there, there is a road which we can see. So represents urban or agriculture field, while natural features such as forest edges or generally are more irregular or in shape. Like if you see wherever we have cultivated the land or we agriculture fields are, they are more or less, they have a regular shape, okay, or a very standard shape. Like if you see this field, especially this track field or the ground where people would be using it for what we call a jogging track or something like that, or a ground for playground and all the things. The farm or a cropland irrigated by rotating sprinkler could appear as a circular shapes also. Like wherever we have a farm and all the things, those could also look into a circular shapes. Okay, patterns refer to the special arrangement of a visibly discernible object, typically an orderly repetition. Like if I'm taking a farm where orchids are grown or mango farms are taken, similar type of trees are there. So or probably a residential complex I would have taken. The similar type of houses would be there. So that will tell me the pattern of the objects over there and give me an idea about it, what it is. Like orchid with the evenly spaced trees or urban streets with regularly spaced houses are good examples of patterns. Okay, sizes, the object of size, the size of the object in an image is a function of a scale. Like you can see here there is a big structure, this could be a warehouse, whereas you can see there are smaller houses which could be a residential complex for the people who are staying here there. Then you can see the roads, the trees which are grown over here and all the things. So based on the images you can understand what it is, and then so this could be a large building such as factory or warehouse where people would be going for working and all the thing. Whereas you can see on other side of the road you can see a lot of small buildings where would could be indicating a residential complex, or people who are working in this particular location, they might be staying at this particular location. That's how based on the size we can identify what it is. Okay, texture, like we saw earlier in the tone. Okay, so tone gives you the variation in the tone also allows you the element of shape and texture. So if you see here the texture, you can see this is the open land. Okay, this is this grayish white grayish kind of thing is the open land. You can see the trees over here, right? You can see the trees over here. Okay, and then you can see, and behind the trees there is a ground which is probably a grassland kind of thing. Okay, a asphalt or a grassland. A target or a rough surface or irregular structure such as forest canopy result in rough textured appearance. Textured is one of the most important element for distinguishing feature in radar imagery. If you are taking a radar, okay, or a lidar kind of images also, you will see this kind of a variation into the structure. Okay, this will give you the texture of that particular location. Shadow, again different angle we are taking the photograph, so depending upon the lighting effect, okay, when we are trying to take that picture. So you can see there are images of the buildings and then there are shadows which are being created, help to understand the size of the object. Like small building will cast a small shadows, large building will create a large shadows over there. So shadow is also useful for enhancing or identifying topography or landform, particularly in radar imageries. Okay, so shadow is also important to identify the type of the target what we are trying to see over here. Okay, association takes into account the relationship between the other recognizable objects or feature in the proximity to the target of the interest. Like if this image you can see, there is a road. Okay, there are a couple of structures on the either side of the road. There is a water body, you can see there are a couple of ships in the water body where it can be used. There is a ground which can be used for a playground or school playground. It could be that you can see there is a school building over here, and then you can see a ground structure is there which can be used for doing the sport activities and all that things. So for example, if you see this image in our example, a lake is associated with boats, a marina and adjacent recreational land you can see over here. Okay, so this is how the association we can do with respect to the particular target image or image what we see. So different image will give you a different association of that particular object or that particular target. Okay, so types of image and video data. It could be, normally we have seen RGB images, right? But there are infrared images, near infrared images, night visions are there, thermal images are there, multispectral images are there. So we'll see one by one. So this is infrared images. Like you see, like you are holding a python is in the hand. So you can see clearly the structure over here of a python in an infrared image. Okay, near infrared images, you can see the normal RGB image of a same object or the location. How does it gives you in near infrared images? Okay, so you can see the blue tone and the red tone and the green tone for the grass or the dry grass wherever it is. So it gives you different colors to that particular object. So sky is blue, so it is giving me a dark blue color over here. Okay, thermal images. We have seen in the thermal images also of the building wherever it is hot or there is a temperature difference compared to the other differences, you will see the red color and orange color. Wherever there is like on the ground or on the top of the surface of the ground of the which is not hot or something, it will bring you a blue color or a purple images are being created. Multispectral images, like if you see normal RGB images you could see something like this. Okay, but if you see in a multispectral camera the image of the ground, see here you can see this green color or a brown color, a barren land or a not used land. So you can see not used land is basically red or yellow color, or maybe a crop where it is getting developed. But wherever the crop is completely developed or green in color, it is showing in color. So you can see NDV factors is basically 0.035 where it is not used or red color, whereas the ground is completely utilized or for irrigation or for your crop cultivating, it is showing you NDV value as 0.8. Okay, where it is less like yellow and green, okay, so it could be like 0.5 0.6 kind of values it could be given. In between there are somewhere the crop is affected, you can see, or it is a crop is got affected or in a bad shape or some issue is there, so it is change showing the differences into this multispectral images. Okay, night vision, this is basically developed for military purposes, so you can see a picture using the night vision cameras. Okay, introduction to photogrammetry. So based on the images what we capture using different payloads, whether it is a RGB camera, it is a your what we call thermal cameras or lidar images, or even your multispectral hyperspectral cameras also. So photogrammetry is a science and technology of obtaining spatial measurements and other geometrical reliable derived product from the photograph. So earlier this photogrammetry was there, pictures were taken, but those were in a form of a hard copies. Okay, so photogrammetry is nothing but analysis procedure can range from obtaining approximate distance, areas and elevation using hard copy photographs products with unsophisticated equipment. So earlier this was a traditional method, but because of the data available now in a form of a digital, okay, so geometric concept of generating precise digital elevation models, that is DEMs, orthophotos and thematic GIS data. The digital photogrammetry is changing rapidly lately and forms the basis of our most current photogrammetric operations. Like mapping for aerial photographs can take numerous forms and employ either hard copy or soft copy approaches also. Orthophotos, combining the geometric utility of a map with the extra real world image information provided by the photographs, or the process of creating orthophotos depending on existing of reliable dem of the area being mapped. So this photogrammetry environment for the spatial data is growing day by day. I can tell you, like last couple of years back, there were hardly any software available for creating the software type of images, okay, or models what we create using the images, digital images. Now there are hundreds of software available. Like I can give you an example, like Pix4D is available, which can take my data and give me a digital DTM, DEM, DTM, all those kind of data I can generate and access and utilize or see my data what is available in form of images can be give me a models. Okay, a real time model can be created by those images or footages what I acquire through the drones. Okay, this is called as photogrammetry. Okay, so what can drone data analysis do? So image gathered during the mission can be processed using software to sort, organize, and manage the data content within the image. Image processing tool then produces a final data set that can easily analyze and provide valuable business insight. Like all the data what we captured during our power line tower monitoring surveillance activity was put it into the software, and we were able to generate the report for the power board to take the decision what is required. Whatever the defects were there, they were able to get those reports from the images, and then they were able to employ the OEMs to do the corrective measures on a proactive nature. If decide, this data can also be turned into 2D and 3D. As I said, phase 2, whatever the data we gave them, they gave it to one of the software company who was actually into GIS photogrammetry kind of company, which actually turned these images into a 3D models and 2D models kind of thing. Okay, so they were able to see not individually photos, but all those photos were creating, helping them to create a 2D or 3D models. Okay, orthomorphic maps or digital surface models or contour maps also were able to create, storing and analyzing drone data for every mission. Like as I said, we started in Jan, the first set of images were captured for that particular tower. Again after 3 months, again after 3 months, every time we capture, so there was a chronological data was available for that particular tower. Okay, and that was stored into the cloud, and then the software was accessing. So I can see the real time data of that particular tower, like how it was in month of Jan, what was my health condition of that particular tower. After 3 months, after doing the remediational activities, in the next footage of my data, it was giving me a much better data sets and better reporting structure of that particular tower. So that tower might be having a health of, let's say, 10% in a good condition. So 80% or 90% it was in a bad shape. By the time I completed my project after 3 months or 6 months of set of data, that same tower was showing 90% in a good health. So it was showing in a green kind of band. Okay, earlier it was showing as a red for me, whereas for it was when I completed my project after 6 months, the data what analysis and the report what was presented and the real time data what they were seeing over the chronological impact, after 6 months they were able to see that that particular tower is showing in a green segment. Okay, the final report can be generated to share with the key stakeholders or decision makers to review and take further action as needed. So they were having the real time data, and they were able to see the difference into monitoring using the drone and the data what was acquired through the drone. So they see that value was there. Okay, so the board or the management was able to take and were able to get funding for setting up this kind of segment to monitor the data. So depending on the software you utilize, you should able to view your data concisely in following ways. Report the exports. Okay, you can export the report in form of CSV or PDFs or charts or graphics or tables. Platform analytics, including performance figures or orders, missions, inspection, flights, pilots, and data was able. Return of investment, you can track the efficiency, safety benefits, program results. So I told you that they were able to reduce the outages from 65% to 85 percentage. Okay, so almost they have reduced a very good amount of outages happening on the power line towers. Data mapping and navigation, using graphical user navigate across 2D 3D models, visualize on map, and click through images. So I told you that that software, there was a separate company involved who was creating 2D 3D models of that data what was captured using the drones into seeing them into the real time. So there was a portal where you can go to that portal, like how we see the Google Earth. Similar to the Google Earth, there was a portal which was developed for internal consumption, where the board was able to go and see the status of all their power lines. So whatever those 100 towers was given to us, they were able to create a real-time model of that particular those towers, and then click on those towers, and then they can get real-time data about the health of that tower. Okay. So that is how you can view the drone data. Okay, so with that, we complete the topic on the drone data and analysis. You have any questions, query, or we are good? I need only 5 to 10 minutes more to talk about the digital data. Though I have already covered up, but I just want to conclude on with that note. If you are okay with it, or we can do this at the flying zone location also, whatever the way you want.
No, you can do it now if it's okay with the others.
I mean, I think Jaishil had something to wind up and he wanted to go. So
No, no, I can wait for 10 minutes, sir. I
yeah,
have to take
then
my
it's
lap.
okay. Yeah, then it's